We're here at an amazing AWS Energy Symposium 2024. I'm Jordan Bloom, Editorial Director at Hart Energy. I'm joined here by Asad Khan, the Director for Global Refining Optimization at S&P Global, and Henry Potter, the Senior Principal Solutions Consultant at AspenTech. Well, first of all, thank you so much for being here. Really appreciate it. Before we really get into it, if I can just get you to tell me a little bit about your companies and what you're focusing on.
Yeah, so I'm from S&P Global. So S&P Global essentially provides global market intelligence for clients and business from governments, business lines, organizations, and individuals to make informed decisions. And those decisions could guide, assess future investments, stock market information, commodity information, as well as assess sustainability challenges and nowadays energy transition across that whole supply-demand spectrum. So providing information and essential intelligence to plan for tomorrow today.
Yeah, and on the AspenTech side, AspenTech is a software leader in the capital-intensive industries. So think energy, mining, pharmaceuticals, power. And where we started was back in the early 1980s at MIT in flow sheet simulation. So basically taking the chemical engineering textbooks and putting them into software. And over the last 4 decades, we've expanded into really 5 main verticals. The first being the flow sheet simulation, the first principles modeling. The second one is what we're going to talk about today, which is the manufacturing supply chain and the refinery economics. A third one is our APM suite, our asset performance management, using analytics to look at reliability and maintenance. A fourth one is digital grid management, so power, electricity, and then the last one is our geology simulation, our subterranean formation modeling.
Great, no, thank you so much. But yeah, just to get into it now, if I can get you to elaborate on just kind of what challenges we're focusing on and kind of how you came to partner with AspenTech and AWS as well.
So between around 15 years ago, IHS/S&P launched a product called Refinery Cost and Margin Analytics. So essentially, it was a product made out in Excel, which would leverage all the global refining data from refinery capacities, utilization rates, crude blends, pricing, and would push that data into an Excel model, which would basically generate yield data and cost and margin data. Now, what was the huge challenge with that was scalability. Since we were dealing with so much data, with capacities, we have more than 700 global refineries, we're talking about 2 to 3 million data points. We were limited with the capabilities of Excel. So we could not scale it. And then obviously the model was also based in Excel. We could also wanted to have some optimization capabilities in the model as well. So 2 years ago, we decided to take a different direction on that front. So we decided that, okay, with so much data, since we have to scale it, we have to enhance a lot of our capabilities in the model, we decided to go towards the cloud options. So the first step in that front was, how can we take all our databases in Excel and move them into cloud, leveraging AWS, Databricks, and Snowflake and others. And then we also decided to do the same thing with the output of the data. But the bottleneck came out where the model was still residing in Excel. So that's where we decided looking into different optimization models that are in the market right now that current oil and gas industry uses. And then AspenTech's Aspen PIMS model is basically the world leader in refining optimization world. So we decided to go with Aspen. So at that point, we developed a proof of concept first, that if it's even possible to do something like that. And then once the proof of concept was developed, we approached Aspen that we have developed this model inside your own software that we can connect all the millions of data points, run it through your software, and get the results out all in the cloud environment.
Very good. Do you want to?
Yeah, that's absolutely right. Where taking RCMA from where it was to where it now is was leveraging PIMS as that optimizer. That's the engine underneath the hood of this offering, of this solution. So for those who may not know, PIMS is a refinery LP model. Linear programming is a mathematical technique. And in layman's terms, it's, we're in Houston right now. If there's a refinery down the road and they were looking at what type of crude oils am I going to bring into my plant? Do I want West Texas? Do I want Western Canada? Do I want some crude oil from Europe, Asia, some combination thereof? They're leveraging the PIMS software as that engine to figure out that optimization, right? What type of product mix am I going to have? What type of feedstock mix? And so that's where PIMS played a crucial role here. And looking at the refinery benchmarking solution that RCMA is, and being able to optimize, carry all the properties and those type of chemistries that you care about. So yeah, PIMS is really the heart here, the engine of the solution.
Yeah, and the advantage that we got from all this was initially when we used to run the refining model in Excel, we were looking at 700 refineries, 5-year historical data, 10 years forecasted per quarter. So it's like 60 cases or scenarios per refinery times 700. So it's around 35,000 to 40,000 specific data points that we're looking for each refinery. Now, in Excel, when you're running that sort of data, of course, the speed, the capability, even at one point, number of rows inside Excel, we would run out of. So we had to run it in batches or manually, and then prone to human errors and all those sort of things. When we started leveraging AWS and moving all these databases into the cloud, and when we figured out that Aspen has a solution in the cloud environment for PIMS, we decided to think, how can we connect all this data into the PIMS environment and have something more robust and being able to scale it as well. So when we moved all those databases into the cloud work, and then we developed the APIs that Aspen recommended to communicate with their software, that's where we decided to make a model that can mold itself to any refinery configuration in the world, which is also new in the Aspen world, because most of the times in the refining industry, they have PIMS models which are specific to refineries, or sometimes specific to 2 or 3 refineries, but not one model that can be molded to 700 different configurations, right, or 800 or 1,000. So once we developed that proof of concept, we thought this is doable. And then when you connected it, so almost 6 months or 8 months ago when we were testing this, we were running almost 45,000 cases to 50,000 cases. So cases are the same scenarios per refinery that I was telling you. It was taking us 4 to 5 days to run that. We've just launched a product 2 weeks ago. And at this point, because of the high performance computing that Aspen offers and AWS offers, we were able to bring that speed down to, we are now running 40,000 cases in 4 to 5 hours, which is essentially 2 seconds per case.
And I want to add some context there, because both Assad and myself, we come from the refinery side where we both were using PIMS at the plant and doing it. And when the legacy PIMS that we would use in that role was a desktop version. And you bring out the 45,000 cases, that this current solution's offering. Well, back when we were at the plant, we're maybe doing 20, maybe 50 of these cases, or another word for it is a what if scenario. So I mentioned this hypothetical refinery in Houston. I might be looking at a WTI and 10 different prices for it, right? That'd be 10 what ifs. So at my refinery, at your refinery, we would run the legacy PIMS and try to figure that out. And it would take time. Sometimes you might submit a job, go get a coffee, and come back. But with the new RCMA solution, it's the Aspen Unified PIMS. It's now no longer in the desktop, but we brought it. It's a browser-based solution in the cloud. So you have that high-performance computing power where we can scale. And with a partner like AWS, we can really take this to the moon and continue to do an nth level of cases, what-if scenarios.
Yeah, and the other advantage that this brings is, in the Aspen world or in the refining world, you had to be a linear programming engineer to run these models in the PIMS world. What we've essentially done is we've basically made it easier for anyone to be able to do an LP analysis in RCMA. So we've allowed that capability in our Platts Connect platform, where anyone can go in there, just select any data, like Henry was mentioning around crude oil, whichever crude oil, what prices or what even refinery configurations they want to run, and they can do that at a click of a button. Just change the parameters by, and then click it, and within a few seconds they will get all the results from an LP model coming out of it. Now, this does not require any LP training. Anybody can sit and do that, and which is very, very advantageous to the trading industry or other refining industry, where he can actually go and do any investment analysis, turnaround analysis, impacts of changes of prices, which is nowadays ever since COVID and other geopolitical situations, the oil prices are constantly changing, refining margins are constantly moving around. How you can strategize using optimization software to immediately make informed decisions.
I've teased Assad on this point before because I've said what he and his team have done is they've democratized LP modeling, the mathematical technique in the refining setting. Often if you go to a plant now, whether it be a petrochemical plant or refinery, you have someone that is a very experienced subject matter expert running these. Often in LP modeling world, it's a career. People will make a career out of this field. And what RCMA has done is brought this mathematical technique to the masses. So now someone who might be in banking on a commercial team, someone at a private equity firm, someone who's looking at the risk analysis and wants to understand the refinery economics, but at a higher fidelity level, that's what RCMA is doing. So you've democratized LP modeling. Thank you.
Yeah, so in that democratized vein, and maybe to take a little bit of a step back, can I get you to maybe elaborate on why historically really detailed refining information has been so hard to get in a streamlined, digestible fashion, and why also the data is so important? Because a lot of our audience is maybe more tech focused.
So S&P essentially, you might know our division Platts, publishes oil prices. Those oil prices are generated mostly on a supply-demand spectrum, of the oil industry in the world. So shipping movements, inventory management, and whatnot. Historically, it was very challenging to get all that data. Now, with all the additional technologies available, the satellite information available, you have infrared satellites tracking turnarounds and whatnot, you can get that within a few seconds and a few minutes, and very validated information as well. The second part of it is, of course, some of the refineries are also reporting now to different organizations like the EIA and the others, with respect to yields and carbon emissions and whatnot, just to be on the right side of the policy of the country, right? So now we have all access to all this data, which was not accessible before. However, S&P obviously has been in this industry for such a long time. They have a lot of databases that have evolved as well over time. So now we have access to all the refinery capacities, design capacities, down to every process unit. Based on the shipping data, we can track what crude blend is moving to which region, which country, and what refinery is designed to run. And then when the yields come out, you can actually validate it against what they're reporting. So this is something that we now have direct access to. And then what do we do with all this data is why RCMA comes in, right? So when we have access to all this data, we need to have a way to analyze it. We need to have a way of validating it, and also how you can use that to leverage any forecasting models that you have, where this industry is going to go, what energy transition technologies you can implement, what carbon emission technologies or strategies you can implement as well. And now with the world moving towards energy transition and biofuels, that is the direction where our RCMA is also going towards, where we can have biofuels capability inside the model or petchem capabilities inside the model, which will allow refiners and different oil industry majors to evaluate if they want to transition the refinery into a biofuels spectrum, or they want to keep within how things are running now.
And to go back on that question too about that barrier to entry, why is it so high? It's to not get too technical, but there are a lot of supply chain technologies in the marketplace. But the reason why you see Aspen Unified PIMs in over about 7 out of 10 refineries in the entire world is because it's property propagation. It is the ability to, yes, take the pricing, and to look at that, the crudes in your products and what that will do for your ROI at a refinery. But it's also, because a refinery is not the same thing as, doing widgets. It is looking at, you care about the sulfur levels, a certain type of cloud points, the different type of process and operating conditions that exist. That's what historically has created that high barrier to entry. You needed someone, he or she, to understand that type of those details in a model. But with RCMA now, powered by Aspen Unified PIMs, you can have that investment banker or that trader run these what-if scenarios, and they don't need to know about, the sulfur level and this heavy Western Canadian crude is this amount. This is not hitting the FCC in a certain way, or there's a bottleneck over here. It's now allowing them to get that mathematical expertise at a much lower bar.
Very good. So obviously y'all have accomplished a lot already. I'm just curious, what's kind of next on the roadmap to success, so to speak?
So now we've started, we've started launching the product. After 2 years of, rigorous development, validation of results, the first phase of the product went out 2 weeks ago. We have to go to market. And now we are going to be launching phases of this product in terms of, I mentioned, scenario manager, where clients can bring in their own data and run it. The biofuels capability coming in, basically allowing refiners to analyze between standalone and integrated or co-processing refineries. And then you also have petchem integration coming into the model, carbon emissions and energy transition technologies. All of that is going to be part of the new direction that we're going to be taking in the near future.
I guess that'll keep evolving with biofuels and sustainable aviation fuels and everything else. That's very good. I'm just curious too, with your partners at AspenTech, AWS and all, just if there's anything you want to highlight in terms of how you're measuring successes and milestones, if you want to get into the weeds anymore.
We talk about the what-if scenarios, those cases. And so when Assad and I used to run 50 cases, 100 cases in our PIMS model, well, now the fact that we're running 45,000 cases, the business problems that you can now consider are endless. I mean, what used to just be what's happening at my plant is when a ship might make a turn in the Suez Canal, or if there's some type of outage of some sort, you can consider these in an evergreen market report. And so that truly is a profound difference. I mean, if you do the multipliers here from 50 to 45,000, and it's not just that we're doing that amount, but it's the real-time effect of it. And having a partner like AWS that allows us to scale with a browser offering is fantastic.
Very good. Well, now, lastly, I just wanted to give y'all a chance if there was anything else y'all wanted to elaborate on in terms of company offerings or just refining trends and the future of the industry.
So basically with the RCMA, with the new tool, a lot of times recently when we were testing it and we were looking at the results internally before we went commercially, we were also looking at how the results align with what the industry is doing. And based on this new RCMA and leveraging PIMs, we were able to accurately predict exact price curves and any refinery shutdowns that were about to happen. And then what we're doing now is we are in the immediately next phase, we're going to be linking live turnarounds out in the global refining industry and bringing them inside our CMA to evaluate the impact of yields and margins. So anytime, because of any storms or any emergency shutdown for any process unit that happens globally in any refinery, our models are going to pick it up real time, conduct the analysis, how much that impact would be on the crude runs, on the refining yields, and how that is going to impact the supply-demand spectrum of that whole region, and it'll be published in real time. So that's another one that we wanted our clients to know that this is also coming, which is we're about to launch that in a couple of weeks' time. And very advantageous for oil traders as well, because not just that you can do your own analysis, RCMA is also going to provide you with netback calculations of different crudes. You can do crude evaluations on specific assets to find out where this crude is how much this crude is profitable to this refinery, and base your trading decisions on that. and which is something that before it used to be done at a very lower level, or very because of course, that Henry mentioned, it used to be a career to be an LP engineer, to run these or have the skills to run this. Now you can do it at the snap of your fingers within just pressing a couple of buttons on Platts Connect.
Yeah. On the AspenTech side, we're going to continue to support our partners. When we mentioned PIMS here, it's been a 3-decade journey with PIMS, where it started as a desktop application where you're writing y equals mx plus b 40,000 times, and then we've moved into a nonlinear environment where it was y equals mx squared mx cubed plus b. Well, now with Aspen Unified PIMS, we continue to move that needle forward with the scalability, with the multi-user environments, and it's something that as you and your team think up new ideas for RCMA, we're here to support you and to continue to drive that solution.
Great. Well, no, thank you so much for your insights. Really fascinating. Really enjoyed it. Greatly appreciated. Thank you so much, everyone watching, and for joining us at the AWS Energy Symposium 2024. Have a great rest of the day.